Okay, hi everyone. Welcome back to Statistics and Data Analysis. Today we're going to have our second lecture about descriptive statistics, and today we're going to talk about summarization. So we know that descriptive statistics or exploratory data analysis basically is talking about some ways for us to describe data. In particular, last week we have talked about visualization. We use graphs to give simple intuitions to decision makers, to graph viewers, and today we talk about summarization. Basically, we will use numbers. We will use a few numbers to summarize a set of numbers. As always, this is the first step before we do any data analysis project, so that we may get intuition and directions for future planning and future analysis. Okay, so if we are talking about a population data set, then we use some parameters to summarize a data set. Or if we are talking about a sample, then those numbers are statistics. As we mentioned, we will use statistics to infer parameters, but that's something to do in the future. Today, we don't need to distinguish between these two concepts. We only need to know, okay, there are some things that we may use. And there are three different things to measure. Either we want to measure the central tendency of a set of data, or the variability of a set of data, or the correlation between two sets of data. Okay, so we're going to have different measurements for different categories. That's our plan for today. So in this first video, I'm going to talk about measurements for central tendency. The first concept that we may have is about median. What's that? It's the middle value in an ordered set of numbers. So that basically means if I give you a set of numbers, which number is at the half of the data set? That means half of the numbers are below it and half of the numbers are above it. So like for example, if I give you several students' grades, and their grades are here, 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 and here, then the middle value obviously is this one. Okay, then we say that's the median of a given set of numbers. Okay, so there are some technical things. If n is odd, like here we have 7 numbers, then we are talking about the fourth number as the median of that 7 numbers. But if n is even, then we use the average of the two middle values to be our median. So because in the future we will always use software to do the calculation, so you don't really need to memorize this formula. All you need to do is to memorize the concept. Okay, so for example, here if we have 7 numbers, 5 is the middle number. But if we only have 6, then the average between 4 and 5 is the middle number, or the median. So obviously, medians can be used to compare the central tendencies of two sets of data. Like if one data set is from here to here, the other data set is from here to there, then it's not very easy to compare these two sets of data because there are so many numbers inside. But probably we may compare their medians. When one set has a larger median, then we tend to say that that particular set is larger or tend to be larger than the other set, okay, by comparing their medians. So the median has a property that it is unaffected by the magnitude of extreme values. Like if I have 7 numbers here, the median is 5. If the largest number becomes even larger, then the median is still 5. Okay? So that implies medians can be calculated from a set of quantitative data or ordinal data, because as long as the data set is ordinal, then we may rank all the values. Then we may find the middle value. But if that's a nominal data set, then we cannot calculate median. The bad thing about median is that a median uses only part of the information contained in these numbers. After all, when we are given all these numbers, we don't really care about their values. We only care about their ranks. Okay? So that means some information is missing, like the value of the extremely large value. So that's why we have average, right? So the second concept that is also very important is means or averages. That just means, well, the arithmetic average of a set of data. Like if I have 7 numbers here, then to find its mean, I need to sum up of them to be divided by the number of numbers I have. Then I'm going to get 5. In this case, all the information contained in these numbers are used. So that's probably why means or averages are used so widely in practice, because the calculation is simple and it uses all the information. Then unfortunately, a means will be affected by extreme values. Like if one number gets extremely larger, then the mean value will also get extremely larger. So we cannot say whether mean or median is better than the other or not. So in most cases, we would suggest you that if possible, present both values simultaneously to describe a set of data. That would make our description much more precise and complete. Okay, and another thing is that we probably want to identify outliers before we calculate a mean or actually any other statistics. Okay, regarding population and samples, we have population mean and the sample mean. We can see that their formula are basically identical. Okay, if I have capital N values, I'm going to sum them up divided by N. That's my population mean. For sample mean, that's actually the same idea. It's just that the notations are different. Starting from now, when we use mu, we are talking about population mean. When we use X bar, we are talking about sample mean in the whole statistics world. And there is still one thing that is important, is about the concepts or the physical meanings of these two numbers. For population mean, because we know this particular number exists in the data set, okay, then mu is actually a number. So let's consider an example. Suppose I'm talking about the average height of all the NTU students, okay? Then because the number of NTU students is fixed and all the heights are also fixed, so the population mean must be somewhere there. It's just that we don't know, okay? But anyway, population mean is a fixed number. However, for the sample mean, it's actually not a number, not a fixed number, because we typically do random sample. So today we ask 100 students about their average mean. Tomorrow we ask another 100 students and we will get a different number. So that means X bar is somewhat random. Okay, we're going to talk about inferential statistics, about how may we use X bar to refer or to infer mu, or use a sample outcome to guess the population outcome. In that case, we really need probabilities because we need to estimate the randomness of X bar, the randomness of sample mean. Okay, we're going to talk about that later in this semester. Okay, let's come back to some measurements. Besides means and medians, we have quartiles and percentiles. What are them? The median lies in the middle of the data set. So that means we can further split the two halves of the data and find their medians in each particular set. So if I have a set like this, then here I have median, right? Then for each set from the first number to the middle, and from the middle to the last number. For each half of the data set, I may also calculate its median, and that gives us the first quartile. Okay, the first quartile and the third quartile. So that's just as simple as we may understand. The first quartile lies in the middle of the first half, and then the third quartile lies at the middle of the second half. For percentile, the idea is almost identical. It's just that now we do not split the data set into 4 pieces. Now we split that into 100 pieces. So we would say that for the P's percentile, P over 100 of the values are below it, and 1 minus P over 100 of the values are above it. Okay? Then by these definitions, we know median is the 50th percentile. Quartiles, the first quartile is the 25th percentile, and the third quartile is the 75th percentile. Okay, by definition. So we probably want to know, well, what's the point of knowing that? Then the idea can be explained in this way. Suppose I have a data set so that I have a few dots like this. Okay, and I have another data set which is like this. Okay, I have one dot here, and a lot of dots around the median, and one dot here. In that case, we probably would say the first set of data is more dispersed than the second set of data, because even though the second set of data have some extreme numbers, but most of the numbers are close to each other. Okay? Then when we describe central tendency, in this case, median and mean are not enough to describe the difference. That's why we need quartiles, for example, because the first quartile is roughly here, the third quartile is roughly here, but for the second set is here and here. Okay, so the difference of quartiles can also help us understand more about the data set. Okay, the last concept is modes. Modes, by definition, is the most frequently occurring values in a set of qualitative data. Like if I have a few students, and here are their favorite subjects. So 3 students choose subject A, 2 students choose subject B, and so on and so on. Then we say the modes of this particular data set are A and F, because both of them have 3 as their frequency, and 3 is the largest. Okay, so the idea is very simple, but that only applies to qualitative data. If I have quantitative data, then modes in that definition is not so useful, because in many applications, all the values will appear only once, or if we are lucky, maybe twice. But that's not a very good way to measure modes. Okay, modes has its physical meaning. It's about the most frequently occurring values. So I know with a high probability I'm going to see this value. For quantitative data set, we probably want to ask, what's the probability for seeing values around this value? Okay, so for a set of numeric or quantitative values, I don't want to ask about the most frequently occurring values. I want to ask around which value I have the most frequency. So instead of finding modes, we typically look for the so-called modal classes. Okay, what's that? So let me explain with this example. Suppose I still have these 20 numbers as the 20 heights of a baseball team's players. Then I may draw a histogram like this. Okay, I can say, okay, from 160 to 164, I have a few students there, and so on and so on and so on. So then I can get all the frequencies of each class. Okay? I know that for the first class, I have 1 student here. I have 1, I have 2, I have 5, 6, and 4, and 1. So then I can say the modal class is the class between 176 to 180. So this is my modal class because this class contains the most values. Okay, that's the modal class. So here are some typos. This should be 4, 168, and so on and so on. So in that case, the modal class would be 176 and to 180. In that case, we would sometimes say the mode of this set of data is the average or the middle point of that particular class. Then for this particular data set is 178. It's the average or mean of 176 and 180. Okay, so that means we are saying that around 178 most values are there. So that means if I'm going to guess a student's height, I probably would guess 178, something like that. Okay, then lastly, let me remind you that because we rely on a histogram or say relies on frequency distribution to find modal classes and find the modes. So that means the way of grouping matters. If I instead choose to group these numbers into only 5 or even 4 classes, then I'm going to get a different value for my modes. That's possible. But in most typical applications, if we have enough sufficiently large numbers of values, then that's not going to create too many troubles. Okay, so that's about central tendency. Thank you.